Now let's open that file again and let's see some more interesting syntax here. First of all, we have a very important concept of variables in scripting to store a value once and then reference it multiple times throughout the script. For example, we may have a certain file that we need in many different commands, so we can save the name of that file once in a variable called file name, which we can write either using underscore like this, file underscore name, or we can also use something called a camel case like this. I'm going to use the underscore syntax, and these are just standards. You can name your variables however you want, and we can assign a value to that variable using equal sign and then the actual value. And let's say that file is config.yaml, doesn't really matter. That's our file, and then we can use that variable in all the commands where we want to reference this file. Now, how do we reference or use the variables that we created in a script? Again, using our echo command, we can say using file, and then we do $, name of the variable like this, using file, name of the file to configure something. Doesn't really matter. So that's basically a syntax for using or referencing variables in a script. Another cool thing about variables is that you can actually assign values to variables that are the output of command execution. So for example, if I do ls and let's say I want to list all the contents in a folder called config, let's say, I can save the result of this command execution into a variable and then reference it multiple times in a script wherever I need it. To do that, the syntax is $, and then wrap the command basically in brackets, and then we assign it to a variable. And let's say these are config files, or all config files that we need. And again, to reference that variable, let's do another echo here, contents of config folder, or you can also write, here are all configuration files, and use config files variable here. And again, let's actually save this and try to execute, even though we don't have a config folder here. And let's see what's going to happen. So first we see our echo command, then we have cannot access config, no such file or directory, same as here. This is the file name, which we used in echo command, and this is basically another echo command which shows nothing because we don't have a config, because ls config command right here basically returned nothing, an empty result, and that's what we have at the end. So basically we have an error in the execution, and this actually may happen very often because we don't always control the environment. So a very useful concept that we use in script files is something called conditionals. So before we execute certain commands that we're not sure is going to be successful, we check first. For example, we check whether config folder exists or not before we do lsconfig, for example, or before we try to open and execute or do something with a file like config.yaml, we check whether this file actually exists on the system. And if it doesn't, maybe we create the folder or file, or we do something else. So let's see how that works. So right here, before we create the variable with lsconfig command execution, we're going to add this conditional. And the syntax for that is if, that's the keyword that allows us to provide a condition, like does config folder exist on the system? And that condition actually goes between square brackets like this. And here we can type config. And to check whether this config is a directory or not, we can do -d. And this expression here between the square brackets basically is called a condition, and it checks whether config is a directory or not. So if this is true, if config is a directory, then that's another keyword. So we do whatever comes after then in case this is true. So we can do echo config or reading config directory contents. And we can also add a logic of what we would do if there is no config directory. And for that, we are going to use else. Again, let's do some echo. This is basically, echoes are just messages or information for you. When you're executing a script, you don't actually need that for command execution. It just adds more information. So let's say if config directory isn't found, then we're going to print the message saying config dir not found, creating one. And then let's actually create a directory called config. And you know the command for that already. It's make directory, mkdir, and config. And once we are done with our conditional logic, also called an if-else statement, because we have if and else conditions here. And once we're done with it, we tell the program that we're done by typing here fi, which is basically a reverse of if. That's just the syntax. And the program will know that this is the start, this is the end of this logic. So again, a recap, whenever we want to check some logic, check some condition, we can write these if-else statements where we check if something is true, then we execute a certain logic. Else, so otherwise, if this is not true, then we execute another logic. And this lets us basically prepare for different scenarios. So let's save this and execute. And there you go. So we have the first echo, then we have config dir not found, creating one, and then we have the two final echo statements. And if I do ls config, right here, we have the config folder that our script created. So now if we run this again, instead of config dir not found, we have reading config directory contents. So basically, the first time we executed the script, config directory wasn't there. So this was not true or false. So the else block got executed. The second time, once the config folder was already created, this was true, or this condition was actually true. So then block was executed. So that's how conditionals and if-else statements work. And what we saw here are also called file conditions. And these are basically a set of conditions that you can execute on file types. So for example, checking whether this name we provide here is a directory. We can also check whether a name provided is a file. So if we do config.yaml, for example, we can check whether we have a file with this name. Apart from checking whether a file or directory exists, we can also check permissions on a file or directory. We can check whether a file is readable or writable or executable. We can also check whether a file is empty or there is actually something inside by checking whether it has a non-zero size with -s. And we can also see whether user ID or group ID is set on a file. And again, these conditions are very useful when we don't actually know exactly the environment where we're executing our script in, and we want to check, is the file empty before we maybe want to overwrite something there. Apart from file conditions, we also have number comparisons. So for example, if I had a variable here, this could be number of files, number of processes running, maybe a file size, so whatever can be represented as a number. And in our case, let's say we have a number of files, which is configured from outside. So let's say this is some unknown value that we can later configure for the script. And since we don't know the actual value, we can check in the if statement. So we can say if number of files is 10, for example, we can have some logic here. We can also check whether it's less than 10 with LT. So let's say if number of files is less than 10, we can execute them in one go. We can also check if it's greater than 10. Maybe we decide it's too many files, so we don't want to overload the system. We also have greater than equal with GE, or less than or equal. And finally, we also have not equal. Again, you can do a lot of useful checks with number comparisons. For example, you can check whether a port that an application is running on is equal to a specific value, or maybe a number of processes running is higher than an accepted value or whatever. So we have file conditions, we have number comparisons. We also have string comparisons, where we basically just compare to a set of characters, to strings. Again, let's say this is a variable that is passed from outside, and let's say this is a group or user group with some value that we can set when executing the script. And here in if condition, we can actually check the value of that string. So we can say if user group equals, and we do the comparison either with single equal sign or double equal sign, like this. What's the difference? Well, double equality is bash specific, while single equal sign is a POSIX standard, which means that it's cross-compatible for all shell programs. So if user group equals Nana, that's a user group name for my user, then I'll have some logic here. Let's say configure the server and else. So if the user group is not Nana, then maybe we echo something like no permission to configure server wrong user group, and end the if statement with fi. So we can compare two strings with each other using these double equal signs. Now, what if we want to check for two different values? So first we want to check whether user group is Nana. If not, then we want to check another value like user group equals admin. And if both of them is not true, then we want to execute this block right here. So how do we do that? Between if and else, we have another statement called else if, which shortly is written with elif, and that takes a condition of its own where we can check again for another value like this. So if user group is Nana, then do this. Else if, so if this is not true, then check whether user group is admin. If yes, then do some other logic like administer the server, whatever. And if both of these are not true, so user group is neither Nana nor admin, then we execute another logic in else. And of course, this logic is not only for strings, but for any type of conditionals. That's basic if else statement. And finally, for strings, you can also check whether this string contains a substring, and we can also check whether string is empty or not. So these are basically conditionals and how you can use them with numbers, strings, or files to check certain conditions and define certain logic in your script based on what these conditions are. Now, in these examples, I mentioned that there could be some values that get configured from outside. Whenever we execute the script, we can basically pass these as parameters or configure them from outside. So how does that actually work? How can we provide values externally to our script that we can then read inside the script or reference by checking its value and doing some conditional checks, etc. And that is another concept in Bash scripting, which is you can actually provide parameters to your script when you execute them. So let's say we want to provide user group as a parameter, and we want to read that parameter here. To read a parameter that is provided in Bash script execution, we have a special variable that we can access using the syntax. Remember, the syntax of accessing any variable is $, like here, or in those echo commands. And then after $, we have 1. So that's going to be the first parameter that we pass to the Bash script. And if I save this and execute the Bash script without passing the parameter first, we have an echo line that says no permission to configure server because we didn't pass in any parameter. And this was basically just empty, right? There was no value here. So both of these if statements were wrong. So the else block was executed. And for better display, let's actually separate the output. And now let's execute our script with a parameter. And I'm going to pass in admin. And I actually forgot to reference this variable here with $, in quotes, like this. So basically we are assigning a parameter variable that we get from outside to a user group variable, and then we're using that user group variable to check its value. So let's try again with group admin. And there you go, we have an output for administer the server when group name is admin. And let's also test with Anna, which says configure the server. So that's basically how you can accept parameters from outside into your Bash script. And then you can reference those parameters by first assigning that to a variable and then referencing that variable. We can also pass multiple parameters to our Bash script to make it even more configurable. For example, let's say we want to pass in this directory name as a parameter instead of hard coding it in the script. So let's say config directory variable name equals, let's make this the first parameter and this the second. So whatever parameter we pass in, the value of that will be assigned to config dir variable, and the second parameter will be assigned to a variable called user group. And now we can use that config dir value in our script. So let's say we want to replace this string here. So again, double quotes, $, name of the variable. So we're checking whether the provided parameter, name of the directory, exists on the system. And then if it does, we print out the contents of that folder. And here again, we create a folder with that provided name. And to have some output here, when we list the contents, let's actually also create a file inside that directory called config.ls .sh, and let's execute. And let's give it another name because we already have the config folder. Let's call this setup scripts. And then we have the group name. Let's call this admin, and let's execute. So first we have config dir not found, creating one, and let's execute again. And there you go, we have reading config directory contents, and right here we have here all configuration files, config.sh. So again, to recap, we provided two parameters to our script by just listing them separated by space one by one. So this way we can provide even more parameters, all space separated, and then we can read each parameter using $sign and digit from 1 to 9. So this is the first parameter, this is the second parameter, etc. And that value that is stored in that parameter, we can assign that to a variable, and then we can use and reference that variable throughout our script, like we're doing it here. And the syntax for referencing variables, as you saw, is $sign and name of the variable enclosed in double quotes. So this basically tells our bash program that we are reading the value of a variable, and we can use that in conditionals as well as different shell commands that you see here. So in our case, we are passing the name of the config directory as a parameter. We are checking whether that directory exists. If it does, then we are basically reading the contents of the directory and storing it or saving it in config files variable that we can then use later in the script, which is right here. And that's basically the syntax for executing an ls command with the variable as a reference, and then we're saving the output of that. Now, the main advantage of having parameters that you can pass to your bash script is having a script that is configurable. So instead of hard coding all the values in the script, we can actually dynamically set different values that we don't want to be hard coded, right? So maybe we want the version to be configurable for an application that we're installing. Maybe we want a Linux username that we're creating using that script to be configurable. So whoever uses that bash script can decide for themselves what they want to call the user or make the group configurable, etc. And parameterizing your bash script is actually very powerful because it allows you to write a script once and then use it for many different use cases by providing different parameters. Now, there is actually a second way of passing values to your bash script or providing values to your bash script externally. And that is by explicitly reading user input. So let's actually get rid of all these lines here and start with a fresh state. And as we saw in Vim tutorial, we can switch to the command mode and then do dd, and this will basically remove the lines one by one, or we can do d and then number of lines they want to delete, like 10, and d again, and this will basically delete 10 or more lines. So now let's say we want to ask whoever is running the bash script for their input, because maybe they don't know that the bash script actually expects parameters, or maybe there is some sensitive data that they don't want to pass in as a parameter, but we want to read that explicitly from the command line. So let's see how that works. Let's do echo reading user input. And the way we can read user input in our script is using read and then prompt with -p. And this prompt is basically what we present the user. So we say, please enter your password. So this is the prompt. And then obviously we want to save whatever the user entered into a variable. In case of parameters, we had the parameters automatically saved into a variable called 1, 2, etc. So we can reference them using $1, $2, and so on. Here we actually have to explicitly name the variable, which will store the user input, and we can call it whatever we want. In our case, I'm going to do user password like this. And obviously, you can use the password to authenticate the user or do whatever, make some calls to a service with their password. In our case, we're just going to echo it. Obviously, this is not secure, but this is just an example. So we're going to echo back the password. Thanks for your password. And then the actual password value. And let's execute this. Without parameters. And there you go. We have reading user input, echo, and then we have a prompt. You see this blinking cursor here, which is waiting for our input. Please enter your password. Let's say this is my password, and it just echoes it back to me. So using read and the prompt, we can basically ask for any number of user input that we may need in our bash script. Now, going back to the parameters concept, for passing values to our shell script, what if we don't know how many parameters user will provide? Or what if we just want to accept any number of parameters without specifying exactly how many it should be? So how do we know how many parameters user actually provided to our script? And to show that as an example, let's do echo user, and then the first parameter, and then we have group, and the second parameter, and that's it. And now when we execute, let's do user and group, and let's do another parameter here, like a file name. And let's also do a directory name for the location of all the scripts, like this. And if I execute, you see that the first two parameters were read just fine, because that's what our script accepted, user and group. However, the other parameters were ignored. So how do we actually rewrite our script so that we can handle accepting and actually reading in all the parameters that the user provides? First of all, we have another special variable that reads, or that basically stores the values of all the parameters that were provided to the script. So right here, I'm going to do all params and then do $, and this asterisk character here. And if I save this and execute again, you see that the $asterisk special variable actually prints out all the parameters that we provided. So we have a variable that gives us access to all the provided parameters. And no matter how many parameters we pass in here, we will have them all in this special variable. We also have another special variable which gives us the number of parameters provided. And that is $ and pound. And let's test that again. So we have 5 parameters and the actual values of those parameters. Now, how do we actually read all those individual parameters one by one in our bash program? Whenever we have a list that we're working with, list of numbers, list of characters, lists of strings, list of files, whatever you name it, we are working with a concept called loops. So loop is basically a program that runs over and over again and executes a specific logic for each individual item in a list. So in our example, let's actually remove this too. And let's say we want to go through all the values that we have as parameters, whatever user provided, we don't know. And we want to execute specific logic for these parameters. And to read these parameter values one by one from the parameters list, we're going to use what's called a for loop. And the syntax for that is for, and then we reference the individual value in the list by name, which is whatever we want to call it. Let's say param or individual parameter, whatever, in, and now we have the list of parameters that we want to go through one by one. And for that, we know the syntax is $*. And now for that individual value that we have here that we're referencing, so for each parameter in that list, we want to execute some logic. And to do that, we have, again, another keyword called do. And we're going to indent that a little bit. And the do block basically will contain the logic that we want to execute for each specific element in that list that we are going through. In our case, let's just print out the actual values one by one. So I'm just going to do echo and param. And just like my if statement, in order to tell the program, hey, we are done here, we are going to do done. And that will be it. So now, a couple of things to mention here. First of all, we have this indentation just like we had with if statements. And this is basically just for us so that it's easier and cleaner for us to read. For the program, it doesn't really matter. Actually, we can write this all on one line. The indentation just gives a little bit cleaner view of the logic. A second point that I want to mention is that this is basically the same as assigning a specific parameter to a variable called param. Just like we did in the previous cases where we basically read in the first parameter and assigned it to a variable called config file, like this. That's what we're doing here, but instead we're doing this for every element in the params list, and we're referencing them as a param variable, like this. So when this runs the first time, it will see that this is a list with maybe 4 parameters, whatever. It will assign the first parameter to this param variable, and it will echo it. Then it will go through the list again. It will see there is a second element, and it will now assign the parameter 2 to a param variable and then print it, and so on until there is nothing left in that list. So to show that execution, let's run our script. And when we do not provide any parameters, you see that nothing happens in the for loop. Basically, we don't see any output. Now let's do name and last name. And let's actually execute our previous example with 5 parameters. And there you go. So we have each value in the parameters list basically output one by this for loop. Now, obviously, just printing the values one by one is not a useful use case. However, you can write any logic and you can execute any logic using for loop for individual values in a list. For example, in our case, we can check for each parameter, for example, whether it's a file or maybe it's a directory name or a location of something. And then based on that condition, we can decide what to do with that value. So for example, let's say we're expecting a location of all the config scripts in the provided parameters, so we can actually check that. So we're going to do if one of the provided parameters is a directory, then maybe we write a logic here that executes scripts in that configuration file. So executing scripts in the config folder. And obviously for all the parameters that are not a directory, so this condition is false, this will not be executed, right? So we have else not a directory. Or we can actually also leave else statements at all, because if it's not a directory, then we just basically print out the parameter like before, and this will apply to all the parameters. And right here we can also do ls. So we can print out the contents of that folder like this, and let's save and execute again. And there you go. So first we have nana, then admin, then config.yaml, and right here is the next parameter, which is setup scripts. And in if statement, it basically detected this is a directory. So if then condition was executed, and ls command ran, and then the last parameter. And the same way you can add conditionals for each parameter. So for example, we check whether this is a directory. For the next one, we can check whether it's a file. We can check whether it's a user and a specific name of a Linux user, etc. And as I said, whenever you're working with lists, you have a list of servers, you have a list of programs, a list of software that you want to install. You are going to use a for loop to go through that list, and for each item in the list, basically execute whatever logic you want. So whenever you want to execute something for a number of times or for each item in a list, that's what for loop is for. However, we have another loop called while loop, which is not used for iterating through a list and then doing something for each item, but rather it's a loop that runs while a certain condition is matched. For example, we want to write a program that pings a service that was just currently started until it becomes accessible. And then maybe at the end prints a success message like the service was successfully started. Or maybe we want to run a script that runs every 10 seconds and basically monitors some endpoint, right? That checks that application is accessible every 10 seconds. So it has to run over and over again in a loop. Or maybe we have a script that installs a software and then waits until the installation is done to validate that a command of that software is available. So wait until a condition like command is available is met. And that is a while loop. And the syntax for that is actually also very simple. We have while, and then we have a condition, just like with if statement. So we can have the same type of condition here as with if statements. So whatever condition we write here, while that condition is true, the loop will get executed. So whatever logic you have in the loop, that will get executed. A very common use case with while, with a very common condition, is running this in an indefinite loop using the condition that is always true. So by hard coding true here, while true, and then using the same syntax as before, do, and then done. And then we have our logic here. So what we do is we run this loop indefinitely, and we have the logic for breaking out the loop inside. For example, let's write a simple program that accepts a user input. So we're going to do read, and then prompt, enter a score, and then we save that score into a variable. Let's call it score. So basically we're going to write a simple program that runs over and over again, asking user for its input for a score, and then we just add all these input scores together. So we basically sum them up. So score, the user provided, will be added to a variable called sum, and we can define that variable outside like this. So we have sum 0. We're starting at 0, and then we basically change this variable that we have defined outside the loop inside the while loop. So every time a user enters a new score, we add that score to the existing value right here and assign it back to the sum variable. So the score will be added and added on each user input. And at some point, we can echo the overall or total score by printing out the sum variable value. However, this loop will run indefinitely, right? Because we have a hard-coded condition which is always true. So we need a way to break out of the loop when a condition is met. So what we're going to do is we're going to let a user complete the program, or basically let the user say, hey, I'm done with this program, I want to quit, or I want to end the program. So we are going to allow user to enter, instead of the score, to enter Q, letter Q. And right here, we're going to validate if the input the user provided here is the letter Q. And again, don't forget the double quotes here. So if this is true, it means user wants to quit the program. So then we want to break. So we're breaking out of the loop. And then we end the if statement. So this will basically execute over and over again, asking user for their input for a score. And whenever user provides a score, a number, it will basically sum that score and print the total score here after each iteration. However, there has to be some way to stop the program and stop the loop execution. So we allow user to enter Q, which means we're breaking the program, we are exiting. However, before we execute this program, there is one thing that we need to fix, and that is the calculation right here. Right now, with this logic, this expression will be interpreted as adding two strings to each other instead of two numbers. For arithmetic operations, we use the syntax of double brackets like this, and that's a holder for an expression in Bash. So this actually fixes the issue, and this will actually be calculated as adding two numbers. And let's save this and execute without parameters. And now let's enter a score, which is 10. We have a total score right away. Then we enter another score like 20. Let's enter 12, and so on. So basically, this program will get executed endlessly because we have a condition called true, which is hard-coded true condition. And it will run over and over again until we actually type in Q instead of the actual score. And if I execute this, the program will end because we have a condition inside that checks for input, which is equal to Q, and then breaks the loop. So the program will end there. Another interesting detail is that Bash has an alternative syntax for the square brackets, which we use for conditionals and if expressions. And the alternative to that is double square brackets. So if you see Bash scripts with double square brackets, that's basically the same thing, but with more features. So it's like an improved version of the single square brackets. One improvement, for example, is that when using double brackets, you don't have to enclose the variable names in quotes. So in general, as you see, Bash scripting has quite a complex syntax, which is not very intuitive. So even though it is very useful in automating DevOps tasks, there are better alternatives for some of these tasks. Using a programming language, Python, for example, or a configuration tool like Ansible, which you can also use to automate some of the same processes. And we're going to learn both of these tools in this bootcamp. However, you will still have a huge advantage by learning all these different options, including the bash scripting, because you will know what are the advantages and disadvantages of each and how they compare to each other. And all this knowledge will definitely make you a very valuable DevOps engineer.